One of the many applications of binary mathematics is memory technology. This memory chip takes 4-digit binary numbers, or 4-bit words, and stores them in a retrievable location as one of the 16 permutations of a 4-digit binary number. In this way, the chip can remember a 4-digit piece of stored binary data when you remind it with a specific 4-digit binary address. Let's look at how binary data is stored and retrieved using this diagram representing the functional capabilities of a typical memory chip. The write or stored process is initiated when you engage the chip's enablers. The ME input activates a memory enable function, and the WE input activates a write enable function. When both the memory enable and the write enable inputs are set to low, the chip is primed to store data. The chip also has two inputs, one for 4-bit data and one for 4-bit addresses. With both enables low, a data input of 0110 with an address input of 0011 will write the data bit string 0110 into address location 0011. Let's also store data 0101 into location 1001. And write 1111 into address 1100. Now that we have these three binary strings stored in memory, let's output the data. To retrieve data from the memory chip, the write enable input must be switched from low to high. With the write enable high and the memory enable still low, the chip can now function to retrieve data. By inputting the 4-digit address 0011, the memory chip will retrieve data stored at this location and output 0110, the original data that was stored. We can output 0101 by inputting the address 1001 and 1111 by inputting 1100. All 16 addresses of the memory chip can function to write and read data similar to what was demonstrated here using 3 memory storage locations.